So today we will start a new data structure, which is your tree data structure. Okay, today we will just discuss the normal basic things, how it looks like, how it works and all. So I'm just directly sharing my screen. Okay, so today we will learn about tree data structure. So all means previously we mainly discussed about stack, queue and linked list, and today we are going to try a new data structure. So tree is completely different from other tree types. This tree is basically follows a hierarchical data structure and it is non-linear. So all the data are stored as a form of nodes. Okay, you can just think about the tree. Tree means it will have nodes and there will be edges. So the basic term is like it's a nonlinear hierarchical data structure that consists of nodes connected by edge, and it is a recursive data structure containing set of one or more data nodes. Okay, and let me show you how it looks like. So in case of tree, there will be a root node, or you can say parent node. You can just think about our families. In family, we have our parents, then we are the children. So a family can have uh, two parents, mainly two parents. But in this case, there will be just one parent. So you can just think about the single parent family. Okay. So in a single parent family, they can have either two children, one children, or there can be many other children. Someone is waiting at the lobby. So our tree looks like a tree. That means all the data are stored in the forms of nodes. Remember the same term we found in case of linked list also. In case of linked list, we had like two fields. One is for data, one is for the address of the next node. So in case of tree, we just have the nodes, but there are some relationship between all these nodes. And these relationships are mainly like parent-children, or it can be sister node and all. So a tree will always have a single parent. Okay, this will be your parent. Then there can be many other nodes, and these other nodes will be the children. Okay, these are your children. So all the data are stored in the form of parent and children relationship. So this is a non-linear data structure. Okay. Then again the children can have other children. Okay. And your data can be stored like 7, 8, 9, 10, 2, 5, 15 and so on. Okay. So this is your basic data structure of tree. Then other than this, they have this one I already mentioned. We either maintain a parent-children relationship between, or they can be sister nodes. So parent sister means so this 7 node and 8, 9, these nodes are children of your 7. Okay, then these nodes are again children of your this node. Okay, so for this portion, this is your parent. And for this two nodes, he is your parent. For this two node is the parent. For this node, this is the parent. For this node, this is the parent. And all these nodes, this one, two, three, four, these four nodes, you can say they are sisters. Okay, or you can say just siblings. So you can just think about your single parent family structure is the same. So your root node cannot have any other children. Sorry, parent. It's a single parent. There won't be anything. So this parent, this 7 node, will be the ancestor of your 8. Another term is your ancestor. So for these nodes, this is the ancestor, and for this node also, this is your ancestor. I guess all of you know about our ancestor and descendants, predecessor, and all. Right? So now, see these leaves does not have your any children. So you can say these are nodes. These are also nodes, and these are also nodes. Okay. The connection from one node to the other node is known as your edge. Okay. And these last nodes, these are called leaf nodes. Why? Because these last level nodes do not have any other children. That means leaf nodes are those nodes that do not have any children. Okay. Normally all the last level nodes are your leaf nodes. So there are certain terminologies I just explained just now. So the first thing is your root node. So your root node will be your first node. This is your root node. The topmost node is known as root node. Then subtree means, see in this tree we have three children. For A there are three children B, C, D. That means you can say these three are one subtree, this portion is one subtree, and this portion is another subtree. Okay, so you can say T1, T2, T3 are the subtree of your main tree T. Okay, then see the leaf node. Leaf node means the node of the tree which does not have any children or child. And leaf node are the bottommost node of the tree. So for any node, this last bottom nodes will be your leaf. Okay. Then we have another term is the path. Path means sequence of consecutive edges are called or is called path. That means what? From node A, which is the root node, to the node E, we have to traverse from A to B, then B to E, correct? So there is a path from A to B to E. That is a one part. Okay, then there can be another part too. Means part means when you move from one node to other, then it forms a part. Okay, for this node as well, you can have A, then D, then H. Okay, from D to C you cannot directly move, or from H to C you can directly move. You have to go back and go again. Okay, we will learn about these things later as well, how you can move from node to node. For the basic thing, you can just remember from one node to other node, you will follow a particular path and it will consist of the other nodes. Next is your ancestor node. Okay, your ancestor node, an ancestor node of a node is any predecessor node on a path from root to that node. That means suppose this is your path. Okay, you are following this path. So in this path, that means A, B, E. So B is the ancestor of E, correct? And A is your ancestor of B and E as well. Okay. Now you can see, think about this part as well. Suppose this is your part A to B to F. Then F will have two ancestors. One is B, one is A. Just think about your parents, then your grandparents. Those are all our ancestors, right? Is it clear to you guys? Am I going too fast? Yes, clear. Next, another term is your degree. Degree means what? Degree of a node is equal to the number of children a node has. So if I am asking you what is the degree of node A, what will be the degree? How many children for this A node? 3. Yes, correct. So for A node there are 3 children. So degree of A is 3. Now for degree of C, what will be the degree of C? What's the degree of C? 0. Correct. And for B and D, the degree is 2 because there are two numbers of children. Next comes your level number. So each node of the tree is assigned a level. So level will always come from the top nodes. That means your root node is at level 0. Then the next level will be the children of A. Then next level will be children of the B, C, D and all. So level will always go downwards. 0 level, level 1, level 2. So your leaf nodes will be at the lowest level. These are the leaf nodes, and your root node will be at the highest level. Or you can see the opposite actually. The root will be at 0 level, which is the low one, and for the leaf node will be at the highest level if you go in a bottom way. So always remember the level will start from the root node, which is in the level 0. So you can also say the other nodes will be one level higher than its parents. मतलब मैं अपने पेरेंट्स से एक लेवल ऊपर हूँ, वो सोच लेना. Okay. So next, height of a node. Okay. How can you find the height of a node? The height of a node is the number of edges from node to the deepest leaf. For example, for this node, what will be the height? You will just find the path to the bottom level. So what's the height of this? It has two nodes below this one. So height of this node is D. Okay. Again from this node, there are just one levels left. So height is 1, and here for the last node height is 0 because they are at the top level. So if your level goes backward, that means your height will go upwards. This is your level. Level you can also say as your depth. Okay, depth and level same, and height will go up. Okay, so height of a tree is the height of the root node or the depth of the deepest node. And depth of a node is the number of edges from root to the last node. Okay, if I am drawing this one, suppose. What is the height for this tree? Height of this node, root node. Okay, go on. There are two edges, so height will be 2. Correct below. What are the levels here? This is a 0 level, 1 level, 2. So depth for this one is 2 and the height of root node will be 2. When I ask the height, then you just check the number of edges from root to the last node. Okay. Now other term is your forest. Forest means it's just collection of your disjoint tree. That means what? Okay. Suppose this is your tree. I can say B, C, D, E, F. So this is a single tree. Okay, this is a single tree. Now if you want to build a forest, what you can do, you can just create separate trees out of it. Okay, this is a separate tree. A, C, N, F. This is a separate tree, and E, N, D. This is a separate tree. So these disjoint trees are known as your forest. ओके मतलब जितने सारे चिल्ड्रन है मैंने उसको सेपरेट कर दिया. नाउ इफ आई हैव अनदर सपोज यहाँ पे फिर से एक बच्चा है तो आई कैन अगेन सेपरेट दिस वन एज वेल. ओके सो इट्स जस्ट द कलेक्शन ऑफ disjoint subtrees or trees. Height and depth clear? Just see again. Level and depth will go downwards. So depth of the tree for the last node will be 2, but height will be 0. Okay, then there are some other terms like visiting. Visiting means checking the value of a node when control is on a node. So I can say for if you start your traversing, okay, let's see the term traversing as well. Traversing means passing through a node in a specific order. Okay, traversing means suppose from this tree you want to traverse from A to E. Okay, so the path is from A, B, and E. This is your path. Path means you have also traversed the tree from A to E. You have traversed through this way. Now, when you traverse from B to E, you have visited the node B. So B is like your visiting node, A is your source node, and E is your destination node. So if I'm saying, suppose this one is another, I'm telling you your source should be A and your destination should be this one. Okay, this one. So what you will go, you will come here, then here. So in this part, C is your visiting node. Okay, the concepts are very simple actually. Just the structure is different. Okay. Next we have key. Key means it represents the value of a node based on which a search operation to be carried out for a node. Okay. So in this, where is the other node? Okay. Suppose in this case I want to search the node F. Okay. This is मैम मीट वाला विजिटिंग नोड होगा. ये वाला ट्री में हाँ करेक्ट. इफ माय पाथ इज फ्रॉम ए टू जी, ये सी वाला विजिटिंग होगा. अभी 2 3 जितना भी होगा. इफ आई एम टेलिंग यू दिस इज द सोर्स and this is your destination. So source to destination जो ट्रेवर्स करोगे बीच में जितने सारे नोड्स आएंगे all are the visiting nodes. Okay, you can again think about the same your bus stop from downtown to your Narengi. Then all the bus stops you can say you have visited those bus stops. Yeah. So all the mid nodes between source to destinations are your visiting nodes. Okay. So key matlab suppose I have a tree here, two, three, five. Okay. Suppose this is a tree and I'm asking you to search the highest number. Okay. I'm asking you to search the highest number. I'm just telling you the data. So if I'm asking you to find or search for the highest number, which one is the highest number? It's 7. So your key will be 7. So based on that, you have to traverse the tree. Okay. Then there are different ways of traversing. We will discuss about those things later on. So if you want to go from this, normally we always start from the left. Okay, that means we always start from the left way. Once we finish searching in the left subtree, then only we go to the right subtree. Okay, and there can be other nodes as well. In case of general tree, one root node can have two, three, four, any number of children. Okay, but the most widely used tree data structure is your binary data structure. Okay, binary data structure means what? Every node will have just two children. Okay, they cannot have more than two children at max. Okay, for a general tree you can have one, two, five, any number of nodes. Okay, each node can have any number of children. But in case of binary, there will be only two nodes per two children per nodes. So there are different types of trees: binary tree, binary search tree, AVL tree, D tree, hit tree, spanning tree. We will discuss about all these three one by one. So these the things we have discussed today is just like general tree. General tree means it can have any number of nodes. And based on the types of trees, the operations will be slightly different. Okay, so one of the operation you have already learned is the traversing. We mainly use tree for traversing. Okay, now can you tell me what is the advantage of tree over your previous data structures like stack, queue, and linked list? Why do we need tree data structure? Think about it. Any guesses? ट्री में ज़्यादा इजी है, हम डेटा स्टेप वाइज रख सकते हैं. Yes, correct. That's correct. See, in other data structures like our array or linked list, stack, and queue, all of them are linear data structure. Okay, that means all the data we stored in a sequential way. Correct? That means what? Whenever we want to search for something, it gives us O(n) time, the maximum number of times, because all the data are stored in a sequential way, even in the linked list. we can just go from one by one. We cannot directly jump from one node to the first node to the last node. Correct? That means what? Array, linked list, stack, queue, all are just linear data structure, and tree is a non-linear data structure. That means what? We can jump from one node to another. So searching takes less amount of time than your linear data structures. So that's the main advantage of your tree data structure. Is it okay? Clear? So advantage is what? We can quickly access any data from the tree data structure. But in case of linear data structure, we have to go sequentially. So time complexity for searching an element becomes half here. Is it clear to everyone? Others, Dular said yes. Abdullah, yes. Okay. So today we have just learned about general tree. General tree, what it does? General tree simply stores the element in a hierarchical order. So it's just like our family structure. Whenever I talk about tree, just think about our family. We have grandparents, we have parents, great grandparents and all. And we right now you can say you are the leaf nodes. You guys don't have children, you are not married, so you guys are leaf for your family tree. Okay, and your great grandparents are the root node. Okay, so in general data structure, tree data structure, the top level element is always present at zero as root. Okay, so root is your level zero, and all the nodes except the root node. It's like file manager of mobiles. Yes, correct. Yeah. Okay. Okay. Yeah, you got it correctly. So can you tell the applications? What could be the possible applications? Insert, delete. Yes, correct. So all type of operations like insert, delete, searching, sorting is very easy and quick if we use a tree data structure. You will see whenever we will do the operation, the tree data structures takes like log n time. For the binary tree, remember the binary time complexity for binary tree is log n. So most of the time they implement the binary tree with the help of binary search using the binary search tree. Okay, so insertion, deletion, sorting, accessing, all these things are very quick. So most of the time they just use tree data structure. Then storing is easier too. And in databases, most of the databases use tree data structures. Again, yeah, there are different types of tree data structures you can see. So different data structures are used in different databases. Then again, compilers use a syntax tree. That's another thing is syntax tree, just to validate the syntax of every program we write. Remember, we use syntax analysis using like stack. Stack we use with the help of what? With the help of expression evaluation we normally do with the help of stack, right? Previously we have learned how we can use the stack data structure to evaluate an expression. Now I'm telling you, it's easier to use tree data structure, and compiler uses a syntax tree. A particular type of tree is used, and that tree is known as syntax tree. And with the help of this syntax tree, they validate all the syntax of the programs we use. You will learn about this syntax tree or normal trees in other subjects later on in later semesters, like flat finite state automata. Then there will be in compiler design. Yes, there's another subject, compiler design, which you will get, I guess, in third year. So compiler mostly uses tree to validate our syntax. Okay, yeah, application I have already used. So remember last time I said we use heap data structure to implement the priority queue. It's easier to sort the things. So there are different trees, like binary search tree is mainly used to check whether an element is present in a set or not. Then heap data structure is used for heap sort and to implement priority queue as well. Then okay, different modern routers are there, so they also use different keys, which is known as price. Okay, then B3, T3 use in databases and compiler, yeah, syntax tree. So that's all for the basic general tree. Is it clear to everyone? The types we will go one by one, because each of the tree, each of the type of tree is like whole new topic. So this is the very general things you have to know before learning about all the other types of trees. Okay, only two students say yes, yes, yes. Others, everyone clear? Okay, good. Okay, then I'm just ending the class here. Stop sharing. Let me take that. বুলি আমিও শুনি আছো, তাৰে আগতে 16th কনভোকেশ্যন হয়, কনভোকেশ্যনৰ কাৰণে গোটেই ইউনিভাৰ্চিটি পাগল হৈ আছে বৰ্তমান। 1 তাৰিখৰ পৰা খুলিব বুলি শুনিছো, বাট নট sure yet. एंड फ्रेशर्स टीम में कौन था? तन्मय और दुलार। क्या चल रहा है? What about the freshers? Ma'am, schedule not ready. I guess we asked you guys to prepare the schedule by Sunday, and it's Tuesday already. Okay, I'll ask your seniors. Okay, we are working on it. Let's see what's there too. Anyone contacted first sem student? First sem student, anyone? No. Yeah, I asked them to select a CR, but things are like they are still taking admissions. only two subscribers. Okay. Okay. I'm ending the meeting now. I have lots of work. Okay. Thank you. So next class is on Thursday. Okay. By Thursday, I should be a bit less busy. Okay. Okay. Bye. Thank you.